Yes. 15th of May 2025 about clustering. Clustering, it's a supervised learning algorithm first. And so we want to find patterns and also data compression. Type of clustering. In type of clustering, there is hard clustering and soft clustering, which is soft clustering. There's fuzzy clustering, which each data point has a probability of belonging to multiple clusters. And type of clustering method. There is partition-based clustering like k-mean and hierarchical clustering, which result in dendrogram, and density-based clustering and model-based clustering like Gaussian mixture model, which assumes that data is generated from a mixture of probability distribution. So we want to do similarity check. Now, 9. K-mean clustering, what we calculating is uh, make sense of it and calculate the sum of distance between centroid and other samples. So we set initial k centroids and assign each data point to ith group whose centroid is closest to data point among all centroid. And after that, we will update centroid based on, let's say there is 3,1, 2,2, and 4,1 in one cluster group. Then we will average them for x features and y features, and we will do it again about clustering. And if result is same, we will finish it. So it's simple and efficient and also work well with large data set. The problem is we should require a specifying k, and it's sensitive to initial centroid selection. Why? Uh, let's figure it out later. And another thing is hierarchical clustering, which has agglomerative method and divisive method. Agglomerative method is bottom-up approach, which is each data point has its own cluster and pairs of clusters are merged. And divisive method is all data points start in one cluster. In one cluster it starts, and splits are performed recursively as one moves down the hierarchy. So linkage criteria for agglomerative clustering, that is complete clustering, single, mean, centroid, and word linkage clustering. We'll see complete linkage clustering first. What we do is, let's say there is data point 1, 2, 3, 4, 5. Which has X features and Y features. Then what we are doing is calculate all of the distance between each other. Then there will be symmetric matrix come out. A symmetric matrix, each point will be same. So let's see only lower triangle part. If we see lower triangle part, then there is minimum distance. And we will cluster each other first. And after clustered each other, we will find out, we make another table, and it 4 and 1 is clustered, so we are making 6, and compare the other 1, 2, 3 with 6, and if something is minimum, has the minimum distance, we cluster each other. So we cluster and cluster, then there is something what is lastly clustered. That it will be lastly clustered, so we can make dendrogram. Complete linkage. This was single linkage clustering, which is used minimum. Complete linkage clustering is different. How does it do? Is there is you first calculate all the distance, and after calculating all the distance, what you do is what you do is, mm, oh, maximum distance. I'm a bit confusing on worth complete math. And divisive clustering, it starts with one cluster, including all samples, which is divisive method. So how it works is select the cluster C containing two objects with the longest distance. Then from it, we will separate the samples. Like this thing will calculate all the distance, and there will be something different distance. Then we will like there is mix. Then we will make another cluster with only that sample which has the max distance compared to other cluster. Then after that, we will cluster one again. So we can also make a dendrogram. Uh, Hierarchical clustering, it has pros, which has no need to specify k in advance. It will be splitted and produces hierarchical structure. Cons is computationally expensive for large data set and sensitive to noise. And we need to because we did to clustering, we also need to measure the metrics with metrics. Uh, First measure what we can use is inertia, which is calculate the distance and also silhouette coefficient. Okay, let's silhouette coefficient. And 44, okay, homogeneity. This is classification method, but you are using it in clustering. And also there is adjusted rand index and low rand index. And contingency table is what you can use. And for the question of optimal number of clustering samples for clustering, you can use elbow method. Like x-axis will be value of how many numbers we use, and sum of square distance. This will be decrease, and as it will be choose wrong, it will be same. At that point, we will choose it, or you can also select silhouette score. Thank you.